analyzers. Here we are looking at rationalizing imaginary numbers, aka dividing, right? 2 days, 2 days of notes here. So we'll start today with single denominators and we'll move into binomial denominators with the next one. So the next day of these notes, okay? So again, the cyclical powers of I are part of what we want to know when it comes to using imaginary numbers. We know that I is equal to the square root of -1. So I squared is equal to -1, right? Because the squared and the radical cancel each other out. So -1 comes out. When you get to square root of -1 times square root of -1 times square root of -1 times square root of -1, or I to the fourth, you end up with a -1 times a -1, which is a +1. And so then that cycle starts all over again, right? So that's what we're looking at here. We always keep our numbers in A plus BI form, right? The real number and then the imaginary unit next to it. So that's how that works. And this is the imaginary unit, right? Okay. So wait a minute. What I just said was that I is the same as radical -1. Well, in our last chapter, all about radicals, we learned that we can never leave a radical in a denominator. So if we have a radical in a denominator, like say an I, then I can't leave it there. So just like we did back in chapter 4, lesson 5 and 6, we couldn't leave those radicals in denominators. So depending on how many terms were in our denominator, we had two different ways of dealing with this. If you have a single term in the denominator, you just multiply top and bottom by the radical, right? Well, lucky for us, we actually only need to multiply top and bottom by an I, because what that will do on the bottom is that I times an I is an I squared. And what we know from up here about an I squared is that it gives me a -1. So that is going to replace our I in the denominator. Meanwhile, since I do it to the numerator as well, I haven't actually changed my number at all. I've just rationalized what I do have. So that's going to be our procedure here, right? That's going to be our procedure here. This is just after Thanksgiving when I'm recording this. So you guys will appreciate this, right? I over 8. So good. That's why the imaginary numbers chapter is the best one, because of all my fun jokes in there. I over 8. Anyway. So we multiply top and bottom by I. What that basically does is just put that I in the numerator for me, leave me a real number in my denominator, because that's what I need to have, okay? I need to have a rational number in my denominator. Can't have an irrational number. I can't have an imaginary number in my denominator. So nice and easy peasy. Let's rationalize these fractions, right? So let's do a couple of them together. We see an I down here. Just multiply top and bottom by I. Notice I do not have to multiply top and bottom by 4I. Could I? Sure. But then I would have a fraction I have to reduce. This keeps me from having to reduce fractions more often than I would normally have to, right? So on top, 3 times I is 3I. On the bottom, 4I times I is 4I squared. Well, what do we know I squared is? We know it's -1. And what's 4 times -1? It's -4. 3I over -4 is my answer. Let's do it again right here. Multiply top and bottom by I. I'm still going to have to reduce this fraction, but you'll see that. On top, you get 2I. On the bottom, you get 8I squared. Okay? I squared is really equal to -1, as we saw above, right? So I end up with 2I over -8. Well, wait a minute. 2 and -8 are both both evenly divisible by 2. So 2I divided by 2 is I, and -8 divided by 2 is -4. And there's your answer. I over -4. Now, does the negative have to stay in a denominator? No. One negative in a fraction makes the entire fraction negative. So that part doesn't really matter. If there's one negative number, the whole thing is negative anyway. Okay? Now, technically, on letter C, this is not an I in a denominator, but I do have to simplify this I. And again, this is equivalent to -1. So really, I have -3 over -2, which is really 3 over 2, 3/2. So that one was not an I had to worry about, but still I had to simplify. Okie dokie. It is entirely possible to have more than one thing, more than one term in a numerator. If you want to simplify your life a little bit, again, just multiply top and bottom by I, because again, my denominators here are single terms. But like I said, if you want to simplify things, going back to the review there. If you want to simplify things for yourself, this is distributing an I, right? But you can just, since that's multiplying by I, you can just type that into your graphing calculator. Okay, so you don't technically have to, oops, let me get that front parenthesis there. So you don't technically have to do the work by hand that would get you to this A plus BI form answer for your numerator. Okay, so you can do that. And you can even type this in on the bottom if you want. But we all know that's going to be -4, right? So you can do that as well if you want. And that is now fully simplified. So that's your final answer. Okay? Let's do it again. Single term with an I in the denominator. So multiply top and bottom by I. And again, that's really distributing up here. But again, I can use my graphing calculator if I want to, right? So 2 minus 3I times I. 3 plus 2I is my answer here in my denominator here. You can also plug this into your graphing calculator if you don't want to actually do the work by hand. Again, I times I is I squared. I squared is -1. 8 times -1 is -8. But I could do this to make sure I'm getting the right answers. Now, what I look for in all my coefficients is, are they all evenly divisible by the same thing? If they can all evenly divide by something, I still have to simplify that fraction further. Here I don't have that, so I don't have to worry, because 3, 2, and 8, not all evenly divisible by any of the same numbers. So I'm done. Now, I've also got to simplify this I squared here. This is really a -1, or yeah, this I squared is really a -1, and -1 times 3 is really -3, and that would have to add with my 9. Or I could just multiply top and bottom by I and type that into my graphing calculator. So there would be a lot of simplifying I would have to do. But if I just type this into my graphing calculator, it will do that simplifying for me. So this is one place where I say take advantage. That's my personal take on it, is take advantage of the fact that this is one thing you can actually type into your graphing calculator and get an answer for radicals. There's nothing else other than conjugates on radicals that you can do that with. So it simplified everything for me and multiplied it by I for me. I get 5 plus 6I. So now on the bottom, -2I times I. I'm just doing this in parentheses because of that -2. I want to make sure the negatives work out right, even though it'll just come out to be a +2, because -2 times -1 is +2. Now I just look at all my coefficients, make sure they're not all evenly divisible by anything. They are not. Good to go. Best joke. Why can't we be together? It's complex. Like a complex number. Guys, one more day of 5-4 notes, so we'll do day 2. Good luck on the homework. Let me know if you need anything. If you do, you know how to email me and get in touch. Otherwise, I shall be seeing you. Bye, math analyzers.